Yeah, good morning, all. Today we have presentation of Dr. Mayuri. So Dr. Mayuri on finite element modeling of metals and polymeric materials by laser-based micro welding process. So before starting her presentation, I would like to give a brief details of her profile. Dr. Mayuri at present working as an assistant professor at the Department of Production and Industrial Engineering at National Institute of Technology, Jamshedpur. So before joining the current organization, she obtained her integrated PhD from the Indian Institute of Technology, Guwahati. So her major areas of research interests include welding, additive manufacturing, numerical modeling, Python, artificial intelligence, characterization and optimization of manufacturing process. So she has published more than 25 papers in international journals, and it includes the conference proceedings also. She has also published two book chapters and two books. She edited two books also, and now under her three research scholars are working, and four MTech projects and 12 UG projects has been completed so far. So Mayuri, Dr. Mayuri, please start your.
Welding and microwelding. So what exactly is microwelding? Then the different sources of laser which are utilized for microwelding. Then the process of joining polymeric material for laser welding. Then the process parameters and the optimization of the process parameters, the effect of the process parameters. And then I will cover the basic theoretical background of the simulation of how to do the simulation of welding process. And at last, I will be describing what are the present application and what are the future scope of laser in welding. So coming to the micro welding, first let us maybe define what do you mean by micro joining. As we know, with the increased miniaturization of the products, all the products are becoming smaller day by day. People prefer using lighter products. They prefer using smaller products. So, therefore, we get the demand for a suitable technique which can join this micro thin product. We can join this very small products in a product is very much a necessity. So people are opting for more and more techniques from which it will work in life. Now there are more techniques highlighted in the slides. That is the solid state bonding, yes, that is by adhesive bonding it is done. Then soldering and brazing. So this is also one of the suitable method. And the last method is fusion welding. So today my topic will mainly focus on fusion welding of laser. How it is accomplished through laser. So if you are trying to understand, first let us understand what is meant by fusion and what is meant by microwelding. Fusion is nothing but melting. Yes. So here the joining is done by melting two or more material to form a solid joint. So what do you mean by microwelding? Now coming to microwelding, it is based on, it is defined. It is nothing different, very different from the conventional welding that you are that you know. It is only that the variants, the process parameters, the machine used, and the beam form is smaller than the conventional one. And with it, the physics, the underlying physics of welding also changes to certain extent. So microwelding can be defined by three major parameters. watt, 100 watt as laser peak power. So for micro welding, you have to reduce it very much. Yes, so you are using lower power and lower speed, not speed, the speed can be high, but you are using lower value of process parameter as compared to the what conventional welding technique. Similarly, the second parameter on which the micro welding can be defined is the type of bead that is formed. Now, what do you mean by type of bead that is formed? How can it be colored? Because if you have looked into any welding process, the beads form. Yes, if that is the main inner bead. Of course, the penetration depends on what? Here, increasing the power, decreasing the resistance. But if you are seeing the direct volume, yes, so if the width, where width to be very specific, is less than 2 mm, yes, less than very small width, 2 mm, you know, wow, how much small it can be. So if it is less than 2 mm, so that you can define it as what? The micro welding, yes. So this is the most important definition of micro welding, that is dependent on the final width, final width dimension. Yes, so it is very small will be this form. And the third parameter which defines is the thickness of the plate or the tabular components that are joined by welding. So, if the thickness, general use is say that if the thickness is less than 0.5 mm or maybe less than 1 mm. Yes, so you can define that as a micro welding. Now, joining a plate with less than 1 mm thickness is also not very easy. So, the main parameters that you have to consider is the same. The laser power, the laser speed, the laser voltage, current, everything will be the same. Yes, but the thing is that smaller values will be used. Now, if the R, supposedly if the beam can be stabilized by using so lower parameters, some machines do what? Some machines can bring up R and cannot bring up a stable R even at 10 ampere. In even if you see, even at 10 ampere, you cannot bring a very stable R. The R will be like that, it may not come in the next moment. It is not stabilized at all. So stabilizing up actually the real challenge. Okay? So now let's come why laser can be used as a micro welding process. Laser can be used as a micro welding process because of its very high energy density. That is the heat input per unit area. Means area is very small. Yes, here and the heat received is very high. Yes, so energy density of laser is very high, and thus it can be focused with very small diameter, and thus it can be used to form a welding of smaller dimension and to join plates of to join thin plates. Yes, so one of the most important thing is that laser can heat the element in milliseconds. Yes, and the heat effective zone. What do you mean by heat effective zone? There magic is comprised of mainly what the weld zone and the heat effective zone. Heat effective zone is one of those zones where the melting has not taken place, but the change in microstructure has been encountered. Yes, so these things are a thing. And the laser, what cleanliness, the precision of the laser, and its ability to deal with the complex part. So this has made laser inimitable for the micro joining process. Different laser in different forms and different sources of laser are utilized for joining plates and tabular components of very thin dimension. Now coming to the application area of micro joining. So where are actually the laser micro welding? It is applied to joining various things in defense industry, in the aerospace industries, and also in MEMS. MEMS is nothing but they are microsystems. That is having what biomechanical and electromechanical part, the component that needs to be connected. Now, it is new events and it is very quick. So, we need some very high subjects besides joining technique. And laser is an alternative for joining the maps as well. So, it has been increasingly applied for joining various materials. So, laser, as we all know, its capability extends from welding, cladding, surface coating to the additive manufacturing. So, laser has no bound. Similarly, laser is increasingly applied in different forms by for joining. Now, what does the laser source? How does the laser source vary from one another? So, it varies depending on material is varying or if certain materials can demand the use of certain different lasers. So it varies on the well penetration capability, it varies on uh, anything sir you were saying? Laser
No, please,
Rajesh,
please, no, please continue, Mayuri.
hello. So it varies, it has what very good precision. That is the fit tolerance is very high. But the thing is that laser one effect of laser is the misalignment. Slight misalignment in joining in the joint of the two plates. If there is slight misalignment also, then the focus, since the focus area is very small, so it may not cause proper joining. So also the thing is that laser needs intensive maintenance. ठीक है तो the equipment itself is very big and it needs very intensive maintenance. Otherwise, slight defect, slight ignorance can cause large damage, large, very big accidents. But nowadays, you can see if you Google it or if you will see some try to see some videos, you can see handheld laser. The laser that you can hold, that you can hold as a torch, and then you can various types of laser that is increasingly applied. I think on the in your previous session also they have discussed the various types of laser, the carbon dioxide laser, which is a gaseous laser, the fiber laser, the diode laser, which is a solid state laser, this laser, and the ambient laser. So all these lasers are available, but most utilized laser for joining in place is the ambient laser. That too in pulse form and the fiber laser which is very high intensity, high energy density capability. So what do you think by pulse? Pulse, I think all of you know that is the laser is not applied continuously in the joining area, in the scanning area. For some milliseconds or for very small seconds, the laser is not exactly stopped but maintained in a very low intensity so that which means does not fall on the main area. So this is but ambient laser in continuous form may not be suitable, but in a pulse form, ambient laser can be effective joining changes. Now this is one of the main phenomenon which you the physical phenomenon which you need to understand and know. That is the heat source. This is for a general welding. This is not specific that only for laser. In any of the welding process, you need a heat source and then which will be focusing on the material and then it will be melting the material and then different zones will be formed depending on the heat that is being supplied from the heat source to the what this material and thus welding what it calls localized melting and solidification. only in the area where the heat source fall, it will be melting and then it will be solidifying depending on the cooling. So now the thing is that the flow of the material while simulating or while understanding the physics, the most important phenomenon that you have to take into account are the various forces that are acting on the well heat tube. Okay, well tube. That is one is the buoyancy force. Always there will be when there is liquid, there is the body force which is the buoyancy force. One will be the surface tension force. What will be the surface tension force? The force that exists only at the what? Top surface. And that force will always be there when a molten material, when a molten Joule is found. So all these forces taken into account defines your well-being microstructure, defines your mechanical properties of the well joint that is being formed. One important parameter is there where you have liquidified the localized zone. That is just where it has formed the what well-being, then it will be in the liquid state, it will try to expand. But the boundary elements, the boundary that is not yet melted, yes, the base material, it will try to give it a contraction force. It will try to compress it. It will not allow it to expand. So, and then when the molten zone will be solidifying, then what it will be? It will be trying to contract, but the boundary will not allow it to contract. So it will be giving it an expansion force. Yes. So during melting, yes, in the molten state, it has experienced a contraction force, that is compressive force, and during solidification, it has experienced a what? Expansion force. In that, what has mainly happened? That this continuous expansion and compressive stress can generate some stress inside the well flow itself. And if this stress exceeds the yield stress, then after cooling down, it will get absorbed in the well zone. The well zone which was earlier flat may not remain flat. For adjusting the extra stress which is then absorbed during the cooling down, heating and cooling process, what it will do? It will bend itself. Yes, so yes, after welding, all the plates are slightly bent from its original flat position. Now, the thinner materials are more prone to bend because it lacks stiffness. For the thicker material, if you use after certain heat input, no distortion. The bending is called distortion or buckling if it is too much waviness. Yeah. So in thinner plates, the problem is more highlighted. What are the different technologies which can be utilized for joining polymeric material? So one difficulty in polymeric material is that it is very low temperature and it is more prone that if it gets very high heat, the residue it can vaporize very easily. So intensive control of the heat that is received by the polymeric material is very important. So that demands the use of reagent. So friction star welding has been utilized for the polymeric material. Ultrasonic welding, that is vibrations are given. This is also utilized. So this slide highlights some of the joining process, but our main focus will be laser, which is increasingly applied for joining of what polymeric material. Now coming to the what laser welding for polymeric material. So laser is nothing but beam of light, yes, but polymeric material, if it is thermoplastics, yeah. So what the plastics, yes. So what it can do? It can make so it can make more generally transparent to light. Yes. So as you have seen in the diagram, the upper part is transparent to something that where additives has been applied. Either carbon where the black coating is given, as we all know, black components absorb all the light that is being focused to it. Yes, and the white components will transfer away all the light. So, like this, the lower component has been given certain additives or coating so that it can absorb all the light focused to it. But that is not always the case. Some of the light will definitely be transmitted through it and some of the light will be reflected through it. So, light, what is it? Absorption plus will be reflection plus transmission. But the upper part is assumed to transmit almost all the rays that is being focused and lower part is assumed to absorb maximum light that is being focused on it. And thus, the light will fall on the lower part, it will melt the lower part, and after melting the zone, yes, the heat of the lower part will be transmitted to the upper part and the joining will be accomplished. So, what is it? This phenomenon, this process is called laser transmission welding, which is a main phenomenon which is used for joining of polymeric material by laser. So these are the various things that you need to take into account. So the laser, all the laser will be having different wavelengths, and at that the laser intensities will be different. Yes, and the beam quality, how much intensity is the beam quality, how much the light it will get reflected, how much it will be absorbed by the component. This is one of the important capability that you need to take into account. Yes, the degree of transmission, as I already told, degree of reflection, degree of absorption. Yes, so all these things defines the what your well zone in a polymeric material. So here it is mainly understood. So what is it? It is that the two parts has to be clamped as tightly as possible so as to avoid any tear gap between it, because the joining is taking place at the mating surface of the two base material. So if the upper part is transparent and if the joining is being done by the heat transmitted from the absorbing part to the transmitting part, to the upper part, then a very tight contact between the two surfaces must be there. So from the next slide we will be able to understand it in a better way. Now you see, the laser has been transmitted completely from the upper part and it is being focused to the lower part, and it has the ray zone describes what? The ray zone describes the melting zone. So, and then after melting, the heat is being transmitted from the lower part to the upper part. And from the upper part, the gap between storage is nothing but a microscopic level gap. So it is not so much of gap is not there. It is for just for the understanding it is given, and then by heating, it will be transmitting the heat to the upper part, and that heat will be causing some melting of the upper part, and then the final joining will be occur. So this is the main basics of laser transmission welding. So now the degree of complexity of joining the transparent or the polymeric material. If it is white and if it is the lower part, the absorbing part is there, then it is the most easiest way to join, because the white part will be transmitting almost all the rays conventionally, and then the lower part will be absorbing all the rays. Yes, so that also depends, like the lower part you can say it can be metals. It is not that this is method is used only for joining polymer one polymeric material with the other polymeric material. It can be used for joining polymeric material with metals. The lower part can be the metals. So from the top part, all the rays will be transmitted and it will be focused on the lower part. So the lower part laser metal will reflect some of it according to its property, and it will absorb most of the laser light, accomplishing the passive yes, and its heat will be then transmitted to the upper part. So this process can be used for joining similar polymeric material as well as polymeric material with metals. Yes, so the lower part can be metals, or the lower part if it is black, then the joining is most efficient. And then difficulty will be black with then, if both the part are black, then the top surface will be well, top surface will be absorbing it. So some criteria, that is that the two material has to be different in that case. It must be such that the top surface is it must be able to match at least 50% of it.